Okay, our final example kind of goes in with what we did yesterday, 18.3. It's similar triangles once again. This time, you'll notice that we only got 2 sets of angles marked equal. All right, yesterday we had all 3 sets of angles marked equal, and similar triangles require that all 3 angles are equal. So that's the requirement for similar triangles. All 3 angles of one are equal to all 3 angles of the other. All right, but we only have 2 equal to 2. All right, so we don't have enough information at this point to say these 2 triangles are similar. But I want you to notice that how many degrees in this triangle? 180. How many degrees in this triangle? 180, right? Now, I don't know what these 2 angles make, but they make some number, right?
Yes.
These 2 angles make the same number, right? So to get the third angle for both of them, I'm subtracting the same number from 180, so I'm going to get the same answer for both of those, right? So that leads us to what's a theorem that's out there that says AA means AAA.
I see.
If you get 2 angles in a triangle equal to 2 angles in another triangle, then the third angles have to be equal, and that leads us directly to our similar triangles. So we have similar triangles here. That's all the information we need. The only other thing we're going to do to you in these problems is they might only give you 1 set of angles equal. That's not good enough. All right? But let's say they left this one off. So let's just pretend. Get a white pen here and erase. That works. Like magic. All right. Suppose they gave us that. All right, and that was our picture, and that's not AA. That's just 1 angle equals 1 angle. That's just A. All right. But these are vertical angles, right? So there's a rule that says we know about that rule. We see this picture, we know these angles have to be equal to each other. And once we get those angles equal to each other, now we got angle, angle equals angle, angle. So that leads us to immediately this third angle has to be equal, like so. The book likes to use these tick marks. I usually go 1 arc, 2 arcs, 3 arcs. That's what I like to do, but it doesn't matter as long as you get it done. Yesterday we used scale factor. Today let's use proportions, just to show you both techniques. The 2 angles here that are purple are equal. 4 and 6 are opposite. Those equal sides, they correspond to one another. These blue angles are marked equal, so X and 5 are opposite those blue angles. And the black angles are marked equal, so the sides opposite those angles are corresponding. The corresponding parts are proportional. And what that means is that if I were to create a fractional proportion here, I've picked triangle 1, triangle 2, doesn't matter which one's which. I'm going to call this one over here triangle 1. I'm going to call this one here triangle 2. The requirement of creating this proportion is every piece of one triangle goes on top, every piece of the other triangle goes on the bottom, with each fraction containing the corresponding pieces. Here's what I would do personally. And this is something, if you think ahead before you start just throwing numbers in here, whichever 2 sides I know both of, I want to put that one in the middle. I'm going to put 4 over 6.
Wait, say that again?
Whichever 2 corresponding sides where I know both numbers. So I know 4 and I know 6. There's no variables. Where it's both numbers. Put that one in the middle. You don't have to, but it just makes the work a little bit more organized and neat. So that's a good place for it to be. So I've decided, by making this decision, putting 4 on top, 6 on the bottom, I've decided all the triangle 1 measures go on top, all the triangle 2 measures go on the bottom. So once you make that initial decision of where you put things, you've decided for the whole problem where things go. I'm in a blue pen now, so 5 on top because 5 and 4 are in the same triangle, and also 7 on top because 7, 5, and 4 are all in the same triangle. So all 3 of these measures, 5, 4, and 7, come from the left-hand triangle. And then the corresponding piece to 5 is X. The corresponding piece to 7 is Y. And notice X, 6, and Y all come from this second triangle here. All right, so that's a good proportion. That's the proper way to do it. If I put 6 on top, 4 on the bottom, it just would have flipped all 3 of those fractions over. It's still a valid proportion. So don't put a lot of thought into where things go initially. Just once you make a decision, make sure all the decisions are the same based on that pit. The reason I like that number 1 to be in the middle is now this proportion here is going to get me what X equals. 4X equals 30. Divide both sides by 4 and reduce, you get X equals 15 halves. And this proportion here is going to figure out what Y equals. 4 times Y equals 42. Divide both sides by 4 and reduce, you get y is equal to 21/2. By putting that numerical one in the middle, you just can work with those two to get x and then those two to get y, and not having to like go across a fraction to kind of do cross multiplying. It just makes your work a lot more organized. So getting that numerical one in the middle is helpful. Again, not required, but just it makes it easier, so it's worth doing.